projects. In this video, we are going to explain about a project titled BotChase graph-based bot detection using machine learning. So now coming to the introduction part, BotChase stands as a robust and intelligent solution against the ever-evolving landscape of bot-based attacks. By integrating machine learning and graph-based techniques, it provides a proactive defense mechanism that safeguards digital environments, fostering a safer and more secure online experience for users and organizations alike. As the battle between security measures and malicious bot rages on, BotChase emerges as a significant ally, driving us towards a more trustworthy and protected digital future. By extracting meaningful patterns and characteristics from legitimate user interactions, the system gains insights into normal user behavior, forming a baseline for comparison. Any deviation from this baseline is closely scrutinized, allowing BotChase to detect and flag potentially malicious bot activity accurately. So, our main objective of BotChase revolves around developing a proactive, accurate, and adaptive bot detection system. By harnessing the potential of machine learning and graph-based techniques, the system aims to safeguard digital environments, making them more secure and reliable for users and organizations. BotChase plays a critical role in mitigating the risk posed by malicious bots, promoting trust and enabling a safer online experience for everyone. The system constructs a graph network of user connections and activities, capturing the complex relationships between users and potential bot accounts. The graph-based approach enables BotChase to uncover hidden connections and identify botnets where multiple bots work in coordination to carry out attacks. So coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows, processor i5 and above, RAM 4 GB and above is required, minimum hard disk is 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first upload CTU dataset. To upload the CTU dataset step involves uploading the CTU, that is Chase Technical University dataset, which is a publicly available dataset commonly used for research and testing in the field of cybersecurity. This dataset contains network traffic data captured from real-world scenarios, including both benign and malicious traffic. By using this dataset, the subsequent steps in the process aims to build a bot detection system using machine learning and graph-based techniques. Second, apply k-means to separate bot and benign data. In this step, the k-means clustering algorithm is applied to the uploaded CTU dataset. K-means is an unsupervised machine learning algorithm used for clustering data points into distinct groups based on similarity. By applying k-means to the dataset, the system aims to separate the traffic data into two distinct clusters, one representing benign traffic and the other containing potential bot-related traffic. Clustering helps identify patterns and similarities within the data, which can be useful for distinguishing between legitimate and potentially malicious network activity. Third, run flow ingestion and graph transformation. After the data has been separated into clusters, the flow ingestion and graph transformation step involves converting the traffic data into a graph-based representation. Each node in the graph represents a specific network entity, that is example, IP address, user or device, and edges represent interactions or connections between these entities. This graph-based representation allows the system to model the complex relationships and interactions within the system, enabling more sophisticated analysis and detection of potential bot behavior. 4. Features extraction and normalization. Once the graph representation is constructed, the system performs feature extraction and normalization. Feature extraction involves identifying relevant attributes or characteristics of nodes and edges in the graph that are indicating of bot or benign behavior. These features could include factors such as the frequency of interactions, the number of connections, or the type of network protocols used. Fifth, run decision tree algorithm. With the graph-based features extracted and normalized, the system proceeds to apply the decision tree algorithm. Decision trees are a popular supervised machine learning technique used for classification tasks. In this context, the algorithm leverages the extracted features to make informed decisions about whether a given network entity or interaction is likely to be associated with a bot or benign activity. The decision tree algorithm effectively creates a tree-like structure of decisions based on the extracted features, leading to the classification of network entities as bot or Benning. Sixth, view graph. The view graph step allows users to visualize the constructed graph, showcasing the network entities, that is nodes, and the relationships, that is edges. This visualization can provide valuable insights into the network structure and potentially reveal patterns that aid in identifying bot-related activities. Being able to view the graph visually can help researchers and analysts understand the network's complexity and gain a deeper understanding of the interactions between various entities. Seventh, exit. The exit step indicates the end of the current workflow or process. At this point, users may have obtained the desired results, such as the classification of bot and Benning traffic, or completed a specific analysis. Exiting the workflow typically involves closing the current session or tool used to carry out the task. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder, this CTU13 dataset. In this we have some binary profile. This is the main Python file which is containing the Python script in it. And here this is the normalized dataset. This is the run.bat file. Instead of executing the program in command line interface, we executed Windows bat file to run the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with our program. Now click on upload CTU dataset button and upload the dataset. Here I am selecting this dataset. And now click on open button. So yeah, here you can see that the dataset has been loaded over here. And now click on apply k-means to separate bot and Benning data. So here on this screen we can see the data size before removing Benning records and after removing Benning records. By removing some Benning records, we can reduce data size set. And now click on Run Flow Ingestion and Graph Transformation button to generate the graph. So here we can see total nodes and edges generated and time taken to calculate between nests, alpha centrally and clustering. Now we generate graphs, and now click on Features Extraction and Normalization button to extract features and to perform normalization on extracted features. So here on this screen, after normalization, I am displaying few records without degree and in degree and weight details. So here we can see Bay refers to between nest and Lee refers to clustering, and AC refers to alpha centrally. All normalized records are saved inside normalized-data.csv file, and you can open and see that file from code folder. Now we have to click on Run Decision Tree Algorithm button to generate training model with decision tree classifier and to calculate matrices such as accuracy, precision, etc. So here after normalization we got total records as 3119 and with 7 columns in degree, out degree and weight, etc. And application split total records into train size as 2495 and test size as 624. After building train model, we apply test records and get accuracy as 100%. Below screen, here this is showing that true positive as 618, false positive 2, true negative 4 and false negative 0. So by clicking on view graph, here we can see our graph. And after closing this, we can click on exit button to exit with this program. So now, coming back to the conclusion part, in summary, BotChase stands as an intelligent and proactive defense mechanism against the escalating menace of malicious bots. By harnessing the potential of machine learning and graph-based analytics, the system demonstrates its commitment to enhancing the security and trustworthiness of digital platforms. With BotChase in place, users and organizations can confidently navigate the online landscape, knowing that their interactions are shielded from the harmful and disruptive effects of bot-based attacks. As technology continues to evolve, BotChase remains a valuable ally in the ongoing battle for a safer and more secure digital future. By constructing a graph network of user relationships, the system gains a deeper understanding of the intricate web of legitimate users and potential bot accounts. This approach empowers BotChase to identify and expose hidden botnets, thereby bolstering its effectiveness in detecting and mitigating sophisticated bot-related threats.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.